Let us start off by asking why build an RC plane when there are so many varieties of RC airplanes available in the market. Many might have answers as for fun, for developing skills, to get instant and more rewards on project completion, and many more. The goal of this presentation is to get you started in the hobby of RC plane and turn you into a successful hobbyist. So let us start the RC plane model. Now we are going to start off building an RC plane from scratch to end with all the details needed. These instructions will show you the basic idea you need to think about and do when designing and building an RC plane. But do remember, until you take the plane to the sky and get it back to the ground, the most important thing is to handle the making and procedure with care and safety. As we all know, building an RC plane is really fun. Figuring out where to start is important. First, we start off with considering the construction of the aircraft and then moving on to the electronics. We start off with considering the aircraft weight and flight time needed. Then we move on with the dimensions of the main wing and then with fuselage length and then into the horizontal and vertical stabilizer. At last, figuring out the center of gravity to balance our overall dimension is necessary. Once we are done with the dimensions, we can move into the electronics of a flight. The electronics should be picked up so that it will give a decent amount of thrust and fair flight time to give a smooth and successful flight. Let us start off with the construction part of the RC model. The weight of the RC plane is equals to 2 kg. As we have seen earlier that cambered airfoil has high lift to angle of attack ratio when compared to the symmetrical airfoil. So here we are using a cambered 2412 airfoil. The graph here shows the alpha versus CL for NACA 2412 and we can see that the CL for 5-degree angle of attack is 0.800. Hence, we will use this CL value in lift to weight equation to find out the wing area needed for our flight. We consider the velocity as 15 meter per second, mass as 2 kg and the intensity as 1.225 kg per meter cube and gravity as 9.81 meter per second. Hence, we get the wing area as 0.178 meter square. According to the rule of thumb, the aspect ratio of a rectangular wing should be 5. Hence, with the equation, we have aspect ratio is equals to span square by area. We get the span of an airfoil. We get the span as 0.943 meter. Now that we are aware of the aspect ratio and the span size, we can substitute both in aspect ratio is equals to span by chord formula to get chord is 0.188 meter. Basic rule to remember is that theoretical lift of aircraft should be equal to or greater than the weight of the aircraft for the plane to rise. Here we substitute all the known equation to get lift is equals to weight, that is 19.6245 Newton is equals to 19.62 Newton. If lift is equal to or greater than weight, then the plane rises. If the lift is less than weight, the plane descends. These dimensions further explained are based on the rule of thumb. It is not a standard method for designing a plane, but it is a very basic level for entry beginners to start off designing their aircraft on paper. Rule of thumb for RC plane design is also considered as a good place to start off. Then you can experiment with changes in dimensions to see what happens further. Fuselage length should be 70% to 75% of the main wing. Hence, we get 72% as fuselage length is equals to 0.679 meter. Distance from back of prop to leading edge should be 15% of main wing span. Hence, we get 15% of prop back to leading edge is equals to 0.142 meter. Aileron surface area should be 10% to 12% of half of wing surface. Hence, we get aileron surface area as 11% is equals to 0.0098 meter square. Leading edge to horizontal stabilizer should be 3 times the wing root. Hence, we get leading edge to stabilizer is equals to 0.564 meter. Horizontal stabilizer area should be 25% of wing area. We get 25% of horizontal stabilizer area as 0.0445 meter square. Elevator surface should be 25% of horizontal stabilizer. We get 0.0111 meter square. Vertical stabilizer should have a taper of 30% to the horizontal stabilizer. Hence, 10% of the wing area should be a vertical stabilizer area. We get 0.0178 meter square. The other should be 25% of the vertical stabilizer area. We get 0.0045 meters square for 25% of the other area. Correctly balancing your RC plane is important for safe flying because an incorrect COG, that is center of gravity, can potentially result in plane being quite incomplete or hard to control the flight. Every RC plane has a specific CG position where all gravity forces act upon the plane and it is the point where the plane balances perfectly. Since we are doing a high wing trainer aircraft which is having parallel wing chord, and the first thing we need to do is identify the COG according to the plane, which is 0.055 meter from leading edge. Quick and easy method is by placing your index finger or middle finger under each wing at a CG position a couple of inches from the fuselage sides. Gently lift the plane up so that it clearly rests on the fingertips. If the nose points down, it means nose is heavy. If the tail points down, it means tail is heavy. This problem can be overcome by using substitute balances or a main battery, or the main battery can be position adjusted as it is the heaviest part of the flight. Add enough or rearrange the inner components so that the plane is balanced correctly and nothing more. Once we are aware of all the dimensions of the aeroplane,
I'm going to start the building process, printing and joining all the pages that confirms the plans. And then I start cutting out all the parts that we will use for our airplane.
Make a printed paper plan of all the dimensions. Cut the parts of the aircraft. Place it on the material like a foam board. Cut the dimensions accordingly. And finally join all parts together to make a strong aircraft body which is ready to carry electronics. Now we are done with calculation construction part of the RC model. Let us move on to electronic constructions of RC model in the next session. Thank you.